Welcome to this presentation on building digital twins that actually work. Today I'm going to show you how we transformed 267 words of chaos into complete project documentation using AI agents. But more importantly, I'm going to reveal why most AI implementations fail and how to fix them. The missing link isn't better AI models or smarter prompts. It's that we've completely forgotten how humans actually work. When we build AI systems that replicate real human processes, including all the messy iterations and reviews, we get results that actually match human quality. Let me show you what I mean. Welcome to this presentation on building digital twins that actually work. Today I'm going to show you how we transformed 267 words of chaos into complete project documentation using AI agents. But more importantly, I'm going to reveal why most AI implementations fail and how to fix them. The missing link isn't better AI models or smarter prompts. It's that we've completely forgotten how humans actually work. When we build AI systems that replicate real human processes, including all the messy iterations and reviews, we get results that actually match human quality. Let me show you what I mean. Before we dive in, let me be clear about what you're seeing today. This demo was built in just 2 days using CrewEye. It's a rapid prototype, not a production system. It shows patterns and approaches, not perfect implementation. The repository I'm sharing is raw, but real. You'll find actual prompts, tools, and patterns you can use as a starting point for your own experiments. The key lesson here is that tool choice matters enormously. CrewEye gave us fast prototyping capabilities. We went from idea to working demo in 48 hours. For production, we use Natin because it provides visual workflows that non-technical team members can understand and modify. Pattern is, use good tools to get quick starts, but achieve excellence through iteration, debugging, and especially observability. What I'm showing you today isn't about the specific tools, though. It's about how to replicate human PM processes digitally, regardless of which framework you choose. This process creates what I call the document pipeline, the critical flow that builds quality through successive refinement. It starts with a raw email, in our case 267 words of stream of consciousness from Sarah at the elections office. The PM agent parses and structures this, but not in one pass. It reads multiple times to extract both explicit and implicit requirements. This becomes a project brief, which the requirements analyst uses to extract and prioritize detailed requirements, 31 of them in our case. But again, not in one shot. The analyst applies multiple methodologies, validates completeness, and iterates. The requirements inform the user researcher, who identifies user types and creates 3 detailed personas. These personas then drive scenario creation. How will Margaret the senior actually use this system? What about Alex, the tech-savvy professional? All of this context, requirements, personas, and scenarios, flows into the story writer, who creates actionable user stories. 13 of them, totaling 79 story points, each traceable back to specific requirements and personas. Finally, the QA reviewer validates everything, checking traceability, finding gaps, and ensuring quality. And guess what? They find problems, because that's what QA does. Each step builds on the previous. You can't skip steps. This is how quality emerges. Let me show you this in action with a real example. Here's Sarah's actual email. Subject line urgent. Need chatbot for upcoming election. The body is pure stream of consciousness. We need some kind of chatbot. Citizens keep calling asking basic questions. Staff is overwhelmed. She lists a few things people ask about. How to vote, where to vote, what to bring. She mentions they have some documentation, an API that sometimes works, needs it to work on phones. Has a 6-week timeline, limited budget, wants Telegram, no NLP but T. That's it. 267 words of pure chaos. No clear requirements, no user definitions, no acceptance criteria. This is what real projects actually start with. Now watch how our digital twin processes this into professional documentation. Here's our agent orchestra in action. The project coordinator starts by reading the email, but notice, it reads it twice. First pass extracts the obvious needs. Second pass identifies what's hidden or implied. Then it identifies what's missing entirely and needs clarification. The requirements analyst takes the structured brief and applies 3 different methodologies: Moscow for prioritization, EARS format for clarity, Circles framework for completeness. It validates its work, finds gaps, and revises. The user researcher doesn't just create personas randomly. It analyzes the requirements to understand who needs to use this system, creates detailed profiles, then develops realistic scenarios of how they'll interact with it. The story writer combines everything: requirements for the what, personas for the who, scenarios for the how, to create prioritized, actionable user stories. And the QA reviewer? It checks everyone's work and finds problems. Because that's what good QA does. Notice how they review each other's work. This isn't inefficiency. This is how quality happens. Let's look at what the project coordinator produced from that chaotic email. Through multiple reads and analysis, it extracted 3 primary objectives like reducing call volume by 60%, 3 secondary objectives around accessibility, 6 in-scope items, including the Telegram bot and AP integration, 5 out-of-scope items like voter registration, 4 constraints including the 6-week timeline, 5 major risks. This isn't magic. This is what a human PM does. Read, reread, structure, identify gaps, document risks. The agent is following the same process, including the rereading we usually forget to mention. The requirements analyst took that brief and created 31 detailed requirements. But look at the process it followed. This is crucial. It applied Moscow prioritization to separate must-haves from nice-to-haves. It used EARS format: entity, action, response, success criteria for clarity. It applied the circles framework to ensure completeness. It validated everything against the original brief. And it cross-checked for consistency. The output includes 19 functional requirements, 8 non-functional requirements, and 4 constraints. Every single one has acceptance criteria. This took 3 iterations to get right, just like a human analyst would need multiple passes to catch everything. The user researcher created 3 detailed personas that represent real users. Margaret Thompson, age 65 to 75, retired teacher with low tech skills, who needs simple interfaces and might prefer voice options. Alex Rodriguez, 28 to 35, software developer who's tech savvy, wants speed and expects mobile-first design. Robert Kim, 45 to 55, administrative assistant who depends on screen readers and needs full keyboard navigation. But the researcher didn't stop at personas. It created realistic scenarios showing how each person would actually use the system. Margaret struggling to type her address correctly. Alex trying to get quick information during a work break. Robert navigating with his screen reader. These scenarios validate that our requirements actually meet user needs. The story writer combined all this context to create 13 user stories organized into 4 epics. Epic 1 covers voting information access with 16 story points. Epic 2 handles location services with 18 points. Epic 3 ensures user experience and accessibility with 13 points. Epic 4 manages system integration and reliability with 32 points. Total 79 story points. And here's the key. Every single story traces back to specific requirements, links to actual personas, and includes detailed acceptance criteria. This isn't generic agile theater. This is actionable development work based on real user needs and clear requirements. The COA review found real problems, and this is important. The overall quality score was 76%, below our 85% threshold. It identified 8 critical issues, including missing executive summary, incomplete acceptance criteria, no research methodology documented, timeline lacking milestones, and budget missing breakdown. The traceability analysis showed perfect linkage from requirements to stories and personas to stories, but only 85% coverage from objectives to requirements. There are gaps, inconsistencies, and missing pieces. This is exactly what human QI would find. The first pass is never perfect. Finding these problems isn't failure. It's the system working correctly. Now let me show you what actually happened behind the scenes, because this is where it gets real. The entire process took 1 hour and 27 minutes, not the 30 minutes you might expect. 3 tasks failed. That's a 30% failure rate. We needed 3 complete restarts. At 14:10, the persona agent outputted garbage. It literally returned tool invocation syntax instead of actual content. The system sat there for 20 minutes in a debugging gap. At 14:29, it restarted from a checkpoint. By 14:38, it continued with lessons learned from the failure. Finally, at 15:31, everything completed successfully. This cost about $5 in API calls, including the retries. But here's the thing. This is normal. Humans restart work too. We write drafts that don't work. We realize we misunderstood requirements. We start over. The difference is we expect this from humans, but somehow expect perfection from AI. The system is designed for this reality, not for perfection. We have built-in resilience at every level. There's a checkpoint after each document, so we can restart from a known good state. Validation catches bad output before it propagates. Automatic retry mechanisms handle transient failures. Humans can intervene at any point, and each agent checks the other's work. This mirrors how human teams actually work. First drafts are rarely perfect. We expect revision. Colleagues catch mistakes we miss. That's why we have peer review. Multiple reviews improve quality. That's why we have approval chains. Iteration is normal, not a sign of failure. With this design, we have a 30% failure rate at the task level, but 100% eventual success at the project level. That's sustainable and realistic. Quality emerges through iteration, and our digital twin replicates this pattern. In Pass 1, we extract the obvious requirements and create basic structure. Quality is around 60%. It's rough, but it's a start. In Pass 2, we identify what's missing and add context. Quality improves to about 75%. It's taking shape. In Pass 3, we cross-check everything and apply final polish. Quality reaches about 85%. It's professional grade. This matches human work patterns exactly. No one writes perfect documents in one pass. Quality comes from revision, and revision takes multiple iterations. When we build this into our AI systems, we get human-level quality. Let me stress something critical that we learned the hard way. Observability is non-negotiable. You must track execution metrics like task start and complete times, token usage per agent, retry attempts and reasons, API costs in real time. You need quality metrics, output validation scores, coherence checks, format compliance, traceability coverage. And you absolutely need debug information, full prompt and response pairs, agent reasoning traces, error categories, recovery patterns. Without observability, you're flying blind. Our logs revealed a 30% failure rate we didn't expect. We saw token usage growing exponentially. We discovered agents outputting tool syntax instead of content. These weren't edge cases. They were normal operation patterns we only found through comprehensive logging. When you build your digital twin, start with logging on day 1, not day 30, when things are mysteriously failing. Day 1. Every agent action, every decision, every retry. Log it all. You'll thank yourself later when you're debugging why the requirements agent suddenly started hallucinating. Throughout this process, you stay in charge. After each document, you review and approve. If something's wrong, you request changes. If context is missing, you add it. If there's a misunderstanding, you correct it. The agents explain their reasoning, why they made certain decisions, what assumptions they're working from. They show their work. Here's how I got from A to B. They accept feedback. You're right. Let me revise that. And they revise based on your input. Here's the updated version incorporating your changes. This is assistance, not replacement. The human remains the decision maker, the quality gate, the final authority. The AI amplifies your capability, but doesn't usurp your control. So how do you build your own digital twin? Start with process mapping in Week 1. How does Sarah actually create requirements? Not the idealized process in your documentation, but what really happens. What reviews occur? Who provides input? How many iterations are typical? Document all of this, including the parts that seem inefficient. And critically, add logging from day 1, not as an afterthought, but as a core component. In Week 2, build the agents. Create one agent per role you identify. Include the review steps, agents checking each other's work. Add iteration loops, rereading, revising, validating. Built-in checkpoints where humans can review and redirect. Set up your observability dashboard so you can see what's actually happening, not what you think is happening. In Week 3, test and refine with a real project. Compare the output to what humans produce. Debug with actual logs, not guesswork. When something fails, you'll have the data to understand why. Identify missing steps. What did we forget about the human process? Improve systematically based on what you learn from your observability data. This approach works for any department. Want a sales team digital twin? Create a lead qualifier agent that follows your STOA process. A needs analyst agent that handles discovery. A proposal writer agent for solutions. A deal reviewer agent for manager approval. Same principle. Replicate how your sales team actually works, not how the process diagram says they work. Want an engineering digital twin? An architect agent for design documents. A developer agent for implementation. A code reviewer agent for the PR process. A QA engineer agent for testing. Again, same principle. Include the reviews, the back and forth, the iterations that create quality. The key insight is universal. Replicate how humans actually work, including all the messy, iterative, collaborative parts we usually ignore. Let's talk real results and return on investment. Our demo transformed 267 words of chaos into a complete project brief. 31 detailed requirements with acceptance criteria, 3 user personas with full profiles, 3 usage scenarios, 1379 points, and a QA review identifying gaps. This took 1.5 hours of execution time versus 40 or more hours of human time. It cost $5 in API calls versus $4,000 in human salaries. That's an 800x return on investment. And here's the kicker. It gets better with each project as you refine the agents based on experience. There are common patterns you'll see when implementing this. The restart pattern, an agent fails, the system detects it, and restarts with context preserved. This is a feature, not a bug. Plan for it. The context growth pattern. Each successive task uses more tokens than the previous one as context accumulates. Plan for this in your design and budget. The review cascade. Fixing one issue triggers changes in related areas, just like human revisions where fixing one paragraph requires adjusting 3 others. The quality plateau. Around 85% quality is realistic for automated systems. That last 15% needs human touch, human judgment, human creativity. Don't chase perfection. Chase good enough for the next human to polish. Here are the key insights that make this work. First, documentation is the context. You can't skip steps in the pipeline. Each document provides essential context for the next. Without proper structure from the brief, requirements, are vague. Without clear requirements, personas are generic. Without good personas, stories lack realism. Second, process beats prompts. Don't focus on writing better prompts. Focus on replicating actual workflows, including all the iteration and validation that creates quality. Third, iteration creates quality. Multiple passes aren't waste, they're how quality emerges. Build iteration into your system design. Fourth, humans stay in control. This isn't about replacing human judgment, but amplifying human capability. Checkpoints are essential. Fifth, failure is normal. Build for recovery, not perfection. Expect 30% failure rates at the task level. Design for eventual success, not immediate success. The paradigm shift is from AI writes documents to digital twins replicate human processes. This changes everything about how we design and implement AI systems. Here's our agent orchestra in action. The project coordinator starts by reading the email, but notice it reads it twice. First pass extracts the obvious needs. Second pass identifies what's hidden or implied. Then it identifies what's missing entirely and needs clarification. The requirements analyst takes the structured brief and applies 3 different methodologies: Moscow for prioritization, EARS format for clarity, Circles framework for completeness. It validates its work, finds gaps, and revises. The user researcher doesn't just create personas randomly. It analyzes the requirements to understand who needs to use this system, creates detailed profiles, then develops realistic scenarios of how they'll interact with it. The story writer combines everything: requirements for the what, personas for the who, scenarios for the how, to create prioritized, actionable user stories. And the QA reviewer? It checks everyone's work and finds problems. Because that's what good QA does. Notice how they review each other's work. This isn't inefficiency. This is how quality happens. To get started, you'll need some tools and frameworks. QA is Python-based and what we used for this demo. It's excellent for rapid prototyping. We built this entire demo in just 2 days. For production, we use Nathan because it provides visual workflows that make the agent orchestration visible and modifiable by non-technical team members. AutoGain from Microsoft is another option. LangChain is more flexible, but requires more setup. This demo itself is available on GitHub. Link in the description. Fair warning. It's raw, not a polished product, but it's real. And you can see actual prompts, actual tools, actual patterns we used. Think of it as your starting point for experimentation, not a finished solution. The key lesson about tools is this: good tools get you fast results, but excellence requires iteration. Start with something like QI to prototype quickly. Add comprehensive debugging and logging. Test different prompts. Try different models. We found huge differences between GPT-4, Claude, and DeepSeek for different agent roles. The tool is just the beginning. The real work is in refining the process.